Hi, I'm Louis, and welcome to Donuts in Any Shape with Houdini. This is a procedural modeling tutorial targeted at beginners, and Takuma has created a great donut in Houdini tutorial. However, occasionally I was thinking about, I would do this differently in Houdini. And by no means do I want a bad mouth here. And Takuma is a brilliant program, and super helpful several years ago when I first started Houdini. But Moritz is fine with another one, so here's my version. Procedural donut in any shape. Big shout out to Moritz. Okay, let's dive into Houdini. First, we will need to create a font node as our starting point. A bold font like Sego UI Black Regular can be a really good option to make donuts. Then we will need to rotate the letters so it lies down on the floor. You can hold down the middle mouse button while hovering over the parameters to quickly change values. Then create a poly extrude node to give it some thickness. Make sure to turn on output back to close the other side of the letter. The default unit in Houdini is meter, and the size of the donut is huge, so we don't have to type in values with lots of zeros later. Then we will convert it to SDF VDB using a VDB from Polygon node. Voxel size set to 0.01, so the shape can be maintained a bit better with higher resolution. Then create a VDB smooth node to smooth out the shape. Radius at 3 and iterations at 7, but it gets slightly smaller after smoothing the SDF values. So we need to expand the shape with a VDB reshapes SDF node. We don't need to change the parameters because the default value is exactly what we need. Finally, we convert it back to polygons with a convert VDB node. The topology is kind of messy now. We can clean it up with an instance meshes node, which belongs to the Side Effects Labs library. You can get it for free by clicking Shelves and find the Side Effects Labs. Click Install or Update toolsets to download it for free. We need to change the target count to 5k to get more faces, so we can add more details later. Now we will need to create a new point attribute using Mask by Feature node, which is available after Houdini 18.5. We will use the mask attribute to control the modifications in next step by conditions like angles. Hit enter and we can see the mask value represented in color. The value falls between 0 and 1. Bottom is 0, top is 1. We want the central part of the donut to shrink in, so the red part should be around the center and both sides should be white, or close to 0. First, change the angle to 180 so it covers all directions. Turn off cast shadow, and then remap the values so the positive areas focus on the central part and both top and bottom can be 0. Make sure to keep an eye on the viewport when making the changes with curves. Then we need a soft peak node, which can push the points outward or inward based on distance parameter. Set it to negative 0.02 to push it slightly inward. And we want to limit the offset using the attribute we generate in the last step called mask. Turn it on and off to check the difference. Let's add some irregularity to it with a mountain node. We need very small values for both height and size of the noise. Finally, we group all the polygons into a new group called base. We've just finished the bottom pastry part of the donut. Now it's time to make the chocolate layer on top. The basic idea here is to cut the top part off with some plane, and then extrude it to a shell with thickness. Let's make the plane first. Create a grid node. Change size to 1 by 1. We can template the bottom part as reference. Then change both rows and columns to 50. Move it a bit higher, maybe 0.15. Then another mountain node for more details. We don't want these spiky shapes, so we change the noise to Perlin and turn off the fractal mode. Now it's smoother. We need to use a Boolean node to cut the pastry into 2 parts with our grid. Shadow mode can make the grid work like a knife. Connect first input to the base and second input to the mountain node. The intersection of the edge is highlighted once we activate the Boolean node. It shows that the geometry is sliced into 2 independent parts already. We need to tick this checkbox so it gives us a primitive group that contains the top part of the geometry. Then we create a blast node, set the blast group to A outside B, and reverse the selection by choosing delete non-selected, so the top part is kept and the bottom part blasted away. Since the top part is cut off with a Boolean node, the topology of the boundary has many irregular points. So we'll need another instant meshes to retopple the polygon. Set it to 5K meshes. Now extrude it again and set the distance to 0.005. We can now template the bottom part as reference. Close the backside as well. We can now use a subdivided node to check the result. Set the depth to 2 for a better inspection. It looks very thin and sharp around the edge after subdivision. We want it to be a lot thicker, and it will also look nicer if the inner part is pushed slightly inward. Looks as if the edge conforms to the bottom part much closer after subdivision. Pick node can do that easily for us. It's a simplified version of soft pick and has only one parameter to control the distance. 0.005 should be enough in this case. And now it looks much better. As usual, append a mountain node to give the whole chocolate crust some natural random features. The chocolate crust is finished. Create a group node to group everything together. Distinguish it from the rest part of the donut with a top group. We can now start to colorize it with a color node. Of course, you don't need to define a color here. You can do that in shaders or after exporting to other software like C4D or Blender. Now we have a new point attribute called CD to control the color of each point. We can colorize the bottom as well. Hold down Shift key and you can select both the color nodes. Click either output area, hold down Alt key when clicking an empty area. You will get a new merge node with inputs connected to the two color nodes automatically. Now we've finished the two major parts of the donut. The next is sprinkles on top. The chocolate layer is going to be the source of the sprinkles. We use a mask by feature node to mask out the area where we hope the sprinkles will be. Mostly the flat part in the middle, not the steep area around the edge. Create a new scatter node to generate points on the top layer. It has a built-in relax function. If we turn it off, it will look way too chaotic, but too regular when it's using default parameters. We can scale down the radii to blend between the two, so the points look a bit random but still separate from each other for a small amount. And it also reduces the chance of intersection when we turn this point into models later. We use the mask attribute from last node to control density, so the points don't appear around the steep edge. Now we create the actual models of the sprinkles. The simplest way is to use a tube node. We close the caps, change radius to 0.5 and height to 2. 6 for columns are enough since it will later be subdivided. Create a copy to point nodes and connect both inputs to relevant nodes. It works similar to the cloner object in Cinema 4D, copying the object from left side to each point of the right side. Now these sprinkles are huge after copying over. Let's fix it by creating an attribute adjust float. By default, this node will create a point attribute called pscale. Pscale is a reserved attribute used widely in Houdini. It describes the scale of a point. Pscale can be recognized by copy to points node and will affect the size of the objects when copied over to points. We can change the value to random between a certain minimum and maximum values, so sprinkles have variations of size. We can also use a color node to randomize the colors of each point. Now it looks better, except that the sprinkles points up and the direction should be randomized to look natural. To do this, we can generate a normal attribute on the base layer. By default, the normals are on vertex layer, but it needs to be on point level to be recognized by copy to points node and control the direction. Change the normal to points. We can see that normals are on points layer now. Click the Display Normal button to reveal the direction of point normals in the viewport. Activate the Copy to Points. We can see that all sprinkles conform to the surface of the bottom layer, but still, it looks like they all face towards the z-axis. We need another vector attribute called Up to change that. Let's create a new attribute Adjust Vector node. Change the name to Up and randomize the value. Now it's more natural than before, but still not enough. You can feel that they all face towards some certain direction. It's because the random values lie between 0 and 1 by default for both x, y, and z axis. And if we change the range to 0 center values, The elements will have negative values for all three axes, and it's truly randomized this time. Can it be pushed further? Yes. All the sprinkles are straight now. It would be a lot better if sprinkles can be bended randomly as well. We'll use a very different method to achieve this. First, let's create a line node. It has 2 points by default. Let's change point count to 3, so we get another point in the middle. Connect it to copy to points node. Remember that bottom layer we see in the viewport is actually just a template node. Now we create a point jitter node. The only purpose of this node is to randomize the positions of all points. If we change the scale to a small value, these little sticks will have a random bend to them. Add a resample node. Turn off the maximum segment length and set the segment to 3. This will make subdivision better when we convert it to polygons later. Polywire is the node that's going to solidify these lines. And we can check the look of these sprinkles with a subdivision node. Once satisfied, group all the sprinkles together and merge it with the chocolate and bottom layer we made before. The last element to make is the sugar lines on top. First, find an empty area. Create a line node. Make the direction to z-axis. We need a few more points to get this zigzag pattern. Using a new node called Group by Range. Change group to point level and select every other point. We can check the status of these points in the spreadsheet. Now make a transform node. Set the group to group 1, which is the one we created in last node. Set the translate to 1 in the x-axis, so we move all our selected points to the right by 1 unit. We need to add a match size node to move the whole structure to the origin of the world, and then resample these lines to add more points. Change the interpolation to interpolate curves, so the overall shape can be a bit curvy. Append an attribute noise node to add some randomness. We changed the attribute from CD to P, which stands for position. Range set to 0 center values. Make the amplitude smaller. Also use Perlin noise with smaller element size. Now let's move everything up a little bit with another transform node. The next is the key step for our sugar line. We will project the lines down to our chocolate layer, which can be done using a ray node. Connect the second input to our target object, which is the chocolate layer. Now it looks like it's doing what we want, but the result isn't stable if we don't specify a specific direction. So let's change the direction from normal to vector. Right-click the directions and delete the built-in expressions. Set the y-axis to -1. This can make sure our lines are forced to project downward under all conditions. Also, we'll need to create point group for all points that are projected. Then, using a blast node to remove all points that were not projected, select the group ray head group, and we want to remove points that are not in this group, so make sure to check the delete non-selected to reverse the behavior. And then another resample node. Set the length to a small value like 0.02. Interpolation mode set to subdivision curves. Copy the transform node to move it up. And the ray node to project lines again. Here we can change the lift to some very small negative distance, so all the points will move up a little bit rather than perfectly lying on the surface. It will make the sugar line more realistic. If we try to blast the points, only the points get removed, but the lines are still connected. We need to use a different method to remove the lines. First, create a group promote node. This can move the group between different levels. We select the group just created and move it to edge level. Edge is a special level that you don't see in the spreadsheet, but you can see the selection in the viewport. All the lines related to the ray head group are highlighted in orange. Check this option to exclude the parts that don't have both ends in the point group. Now add a dissolve node. Select the same name edge group and reverse the selection in the operation. All the floating parts are now removed. We can then use a polywire node to convert the lines into polygons. But the radius is uniform, which can be changed using attribute noise node to affect p-scale. Type set to float and change the name to p-scale. Range should be min-max values, with some numbers I found earlier when making the tutorial. Here we use attribute noise node to change the p-scales for sugarline, but we also use attribute adjust float node previously to affect the p-scale of sprinkles. Both will work and it's actually just a matter of habit. Now we activate the polywire node, select the value in radius, then type at p-scale. This is a simple expression to define p-scale as the input of radius. Let's have a look at the result after subdivision, which I would say is pretty good. Also give the sugar line a new group to separate from others. You can also colorize it to something like Nutella. And merge it with the rest. That's all about the creation of a procedural donut. If we change the input to some other letters, we should get a donut in any shape as input. You can also use a stroke node to paint other shapes, and it should all work properly. Alright, I hope you can learn something in this tutorial. If you find it useful, please subscribe and like this video, and I will see you in the next one.